Hi, I hope you've had a great break. Let's go over some of the problems in the winter packet. I told you that I put up some solutions at the end of the break so you could check your work. And here we are. So let's start with number one real quick. It says if you've got a temperature of 15 degrees and it decreases or goes down by 18, what temperature would it be? And this looks like one of those subtraction problems that you see in elementary school that you think it can't be done, right? 18 is greater than 15, your teacher told you. Can't do that. Well, remember, I'm going to make my pen a little smaller here. Excuse me. Remember, we want to do away with subtraction, right? So what we're going to do instead is we're going to add the opposite, right? And then if it's an addition problem, we can solve this. I can look at the positive and the negative, and I see the negative side has 18 points, so that means my answer is going to be negative. I need to find out, if we're thinking of the teams, right, the positive team and the negative team, which team won? Well, the negative team won, and then we want to know about how much. How much did they win by? And so then we do 18 minus 15 to find the difference between those two scores. We can flip them, right, because addition has the commutative property. You could flip them around as that it's addition. So let's find these. The difference here is obviously 3, right? So the answer is negative 3. It would be negative 3 degrees. Now, you could probably figure that out without doing any of the math, just by thinking about the difference between those numbers. But it's always good to know, how the expressions work, how the math works. All right, I might skip some of these because I don't want to take too long, but some of these are coming up on our interim assessment, so we want to review them. So let's take a look at this one. Unit rate, right? What is the unit rate if Miss Pohl paid $7.20 for 9 pounds of apples, right? So 9 lbs, and that's money. And you might remember that unit rate is we want to know in dollars per pound, right? So unit rate always has one of our units simplified to 1. So for 1 pound of apples. So clearly to change 9 pounds to 1 pound, we need to divide this by 9, right? To divide by 9. At that point, it's a pretty simple problem. That turns out to be 80 cents, right? So remember, unit rate is where one of our units is going to be 1. In this case, they've identified that it's the pounds that we're trying to simplify for 1. They might have asked, how many pounds of apples could you get for $1? That would also be a unit rate, but in this case, they wanted to know per pound for 1 pound. Comparing rational numbers, numbers that are not decimal numbers that continue on and on and on. These are rational numbers. So, quickly, if you ever get confused on these, just think of a number line, right? So here's 0 on our number line. Which is going to be greater? In other words, which one is farther to the right, right? The number line, regardless of whether the numbers are positive or negative, the numbers that are higher or farther to the right are going to be greater. So in this case, negative 35 would be there, and negative 350 would be way down there. In fact, I'd have to cut the number line and stretch it way out. So in this case, negative 35 is much greater. These are a little trickier because I can't really think of a common denominator off the top of my head, so I'm going to use another trick here. I'm going to use, cross multiplication, right? So 9/16 and 4/9. I am going to multiply 16 times 4, and that would be 64, and 9 times 9 is 81. And remember, we'd have a common denominator. That's what we're doing when we're cross-multiplying. I just don't really care what the denominator is, as long as it's the same. It shows me that this one would be 81 somethings, and this one would be 64 somethings. So if I put this on a number line, and remember these are negative now, so if I had negative 64 somethings, it would be right here. And if I had negative 81 somethings, it would be farther down. So in this case, negative 64, whatever the denominator is the greater number. So remember, that was 4/9 was equivalent to 64 somethings. So that's the greater number. So pause these, right? As you're working through these, if you want to write these down or you want to change your answer or check your answer, just hit the pause button, okay? All right. So, Mr. Meyer, I need to get 30 cans of tomatoes in preparation for his family's annual spaghetti dinner. I go to QFC, and apparently I go to Safeway also, and I'm comparing the price of these cans. And I want to know which store has the cheaper cans. And this is a good question, right? I mean, oftentimes you don't have to go to two different stores. You can just look at two different brands in the same store. But let's just figure it out here. I've got 6 cans for $2.70. That's the QFC place. And here's the Safeway. They had 5 cans for $2.65. And the best way to figure out which is the better bargain is to find the unit rate, to find out, well, how much does 1 can cost? Because what's confusing about this is, it seems like, well, $2.65 is obviously cheaper, but you're getting less spaghetti there, you're less sauce. You're only getting 5 cans. And $2.70 is more, but you're getting a whole other can. So we need to somehow make the cans equal. It's sort of like finding a common denominator, just in this case it's the numerator. So let's find out, right? I need to change this to how much is 1 can? And obviously that means divide by 5. And I need to change this to 1 can, and that means to divide by 6, right? So let's do it. 265 divided by 5 is going to be 53 cents, right? I just did 20. Anyway, that's a good mental math problem. This one's a little harder. 270 divided by 6. Sorry about that. So see if we can divide this by 6, right? So 2.70 divided by 6, that's going to come out to be 4 and 24. And at this point I can stop, because if this is decimal 4, that's going to be 40-something cents. I don't know what it is, but it's always going to be cheaper than 53 cents. But we can figure out what it is. I'll do the rest here. 6 goes into 30. It's 45 cents for 1 can versus 53 cents for 1 can. So QFC is cheaper. QFC. Now this isn't a commercial for QFC. I don't know if they're really cheaper than Safeway or not. All right. Excuse me. I think I skipped a page. Oh no, here we are. Sorry. Oh, I'm sorry. I've got the same page scanned twice. Excuse me. Let's go to the next page. Here it is. This one's pretty simple. It says this figure contains 11 squares. The area of the shape is 176 square inches. So I want to find out how much is each square, right? So 176 divided by 11 into 11 equal pieces comes out to be 16. So that means that the area of each one of these guys is 16, right? That sounds great. Oh, but unfortunately the question is, how many inches are in the perimeter? And what is the perimeter? So I need to kind of think about, well, what's the side length? If the area is 16, right, I could do something like this and kind of count them out. But I can also just say, well, what the square root of 16 is 4. So I know that the width of this figure is 4. And this one would be, well, 12. And the side length here, that would be 1, 2, 3, 4, 5 groups of 4. Oh, I miscounted that, sorry. That's 4 groups of 4. That's a width of 16. This is 5 lengths of 4. That's 20. This is 4 lengths of 4. Again, that's 16. This one is 1 group of 4. This one is 12. This one is 12. And this one down here again is 16. So I can just add all those guys up. I'm going to try and simplify it right out of the gate. I see that there are 2 groups of 4, and there are 2 groups of 16, and there are 3. 1, 2. Wait, is that right? No, there's only 2. 1, 2, 3. Oh, you know what? I made a mistake again. I'm not paying attention as I'm doing all this. This one down here is also 12. And And there are 3 groups of 12. So 2 16s, 3 12s, and finally there's a 20. And that should give me the perimeter, right? So I'm going to try and bunch these up. That's 8, that's 32, that's 36, and still 20. Grouping these together gives me 40. Grouping these together gives me 56. And altogether that makes 96. 96 inches in the perimeter. Now remember, perimeter is just a linear measurement. It's just lines. That's a straight inch, not square inches. Okay, moving on. Suppose all the counting numbers are arranged in columns as shown on the right. Under what column with a letter under what column letter, A, B, C, D, E, F, or G, will the number 1000 appear? So I started by looking for patterns here. I thought like, okay, where will 1000 be? And the only one I could see a pattern for is here. And it looks like we're clearly skipping by 7s because these are, well, groups of 7. So it occurred to me, groups of 7, hey, let's just take 1000 and let's divide it into groups of 7. And how many groups of 7 are there? And it turns out there are 142. Let's see if we can knock it out here real quick. I was trying to get rid of that line. Use the eraser. Oh, there's something odd about that. Okay, so 1, go real quick here. We have 300 left. 4, this is multiplication. 4 times 7 is 28. And we're left with 20. And 2 times 7 is 14. And we're left with a remainder of 6. Or 6 out of 7. I'm not going to use a decimal because we're talking about these squares here, and I can't really divide them up. Or we're talking about rows, really. There are 142 rows of 7, and then the last row will be 6 out of 7. So it appears that I would fill up, if we kind of break through here, I would fill up 142 rows evenly, and then I would get to 142. I think that's right. Did I make a mistake here? Yeah, that'd be 142, and then 143, 144, 145, 146, 147, 148. No, wait, I'm sorry. I've gotten myself confused. That's 142 rows. 142 rows of 7. I don't know how much that would be. I sort of forgot that. Okay, so 142 rows. I'm thinking too fast here. There's 142 groups of 7. And what does that come out to be? See, 2 times 7, 14, 28, 29, 994. So what that means is that I'd have 142 rows, and that last one would end at 994. And then on my last row, see if I can duplicate this here. My last row I'd have 995. I'm just going to write the 996, 997, 998, 999, and 1000. It would end up in row F. And you can see that's our remainder 6, right? We had 1, 2, 3, 4, 5, 6 pieces out of 7 were left. Right? We had 142 full rows. And on the 143rd row, wasn't quite filled up all the way. It ended up only being 6/7 full. So, okay. Fraction remainders. Okay, let's keep going.